Okay, in parts of an algebraic expression, there actually are words that we use to describe each part of our expressions. So let's go over some of the vocabulary words first before we start identifying the parts. So in this example, I have 3m plus 4p plus 12. This is an algebraic expression, and remember it's an algebraic expression because we have variables in this expression that we have written above. So each part actually has a word, a definition that goes with each part of our expression. So the first one that everyone knows already is our variables, our letters. So we have M and P, those are both variables in my algebraic expression. We just don't know what M and P stand for yet. 3 and 4 are being multiplied with M and P. They have a special word that goes with them, coefficient. So it means how many M's and how many P's do we have. So 3 and 4 are called coefficients, or what I like to call number before the letter. All right, and then the last part is the constant. This is just a regular old number that does not have a variable attached to it. So this is what we call the constant. So variables is in red, the 3 and the 4 are black. Those are my coefficients. So how many M's and how many P's do I have? And 12 is a constant. So no matter what M and P are, we will always add 12 at the end of this expression. Now, each part also, 3M, 4P, and 12, these are what we call terms. So in this algebraic expression, I have 3 terms. 3M is a term, 4P is a term, and 12 is a term. And for 95 to 98% of the time, no matter what, algebraic expressions have terms that are separated with addition or subtraction signs only. The only cases that doesn't happen is if there's a parenthesis involved. Then we've got 2 terms there. But for the most of the time, you can tell how many terms there are in an algebraic expression by looking at the addition and the subtraction symbols in them. So let's look at 2 examples on identifying the parts of an algebraic expression. Okay, so let's look at example 1. We have 7e plus 8. I have 2 terms in this algebraic expression, 7e and 8. And we describe this as the sum of 2 terms because we're adding and we have 2 terms, so the sum of 2 terms. The coefficient in this problem is 7. 7 tells how many e's that I need. I need 7 e's. The variable in this example is e, and the constant is 8 because I am consistently adding 8 no matter what e is. So if e is 1, we have 7 plus 8. If e is 2, we have 14 plus 8. If 7 is e is 3, we have 21 plus 8, and so on and so forth. So no matter what, we're going to be adding 8 to this algebraic expression. So let's look at example 2. Example 2, I have 2 terms, but I'm going to talk about these parentheses here in a second. I have 2 terms. I have 9 times 4m plus 2 and 3. Okay, so this whole algebraic expression, I have 2 terms. 9 times m plus 4 plus 9 times m 4m plus 2, I can get this out of my mouth, and 3. Now, if I cover up the 3, this part also has 2 terms, and this one we would say the product of 9 and 4m plus 2. So the whole thing is the sum of 2 terms. If I just look at the beginning part with the parentheses, this is the product of 2 terms. And if I go even further and I just ask about inside the parentheses, this is the sum of 2 terms. So this one's a little different, but I'm looking at the whole algebraic expression. The whole algebraic expression has 2 terms, this part and this part. Again, I can break it apart even further and talk about other parts and what's going on there. But if I'm looking at the whole thing, this is the sum of 2 terms. So I hope that makes sense. Okay, so if I'm looking at the whole algebraic expression, the coefficient is 4. That is the number in front of the letter, in front of the variable, and the variable is m. And again, if I'm looking at the whole algebraic expression, I am constantly adding 3. So that is the constant in this algebraic expression. So I hope this makes a little sense when I talk about this whole thing and identifying the parts of an algebraic expression.